Welcome back to another video of Turtles All the Way Down. This is the third video in our series on our scientific search for alien life and intelligence. In the first video, we discussed what scientific evidence we currently have of alien biosignatures in our inner solar system, from the planets Venus and Mars. The second part discussed what we know about the outer solar system and an exoplanet outside of our planetary neighborhood. In those two videos, we focused our attention on biological tracers, what we have termed biosignatures. These consist of any evidence of alien biology, such as atmospheric gases and fossils. In this video, we will begin to discuss what has been found with the other method for searching for extraterrestrials, technosignatures. Technosignatures, as the name implies, are those traces tied to some sort of intelligence. Engineering projects, artificial atmospheric gases, evidence of industry, electromagnetic signals not created from nature, and artificial artifacts are some of the signs of technosignatures. We will not be discussing either those potential searches that have yet to be performed, nor those that have not yielded anything that pertains to ETI. For example, we will not discuss potentially ETI-created atmospheric gases around exoplanets, as none have been searched nor found. Neither will we discuss searches for extraterrestrial artifacts on or around solar system objects, as nothing has yet been even suggestively found in any of those searches. But the technosignature search is perhaps the most exciting in the field, because if any detection is confirmed, it will not only have great ramifications for biology, but also for much of the rest of the human condition, as it will extend its influence to other sciences, arts, politics, religion, and to philosophy such as ethics itself. In science's search for these, have any been detected? And if so, what has been found? That's what we'll be discussing in this video. The search for extraterrestrial intelligence, or SETI for short, has been a scientific endeavor that was theoretically pioneered in a 1959 Nature paper by the Cornell physicists Giuseppe Cocconi and Philip Morrison, and its subsequent experimental search was begun by Cornell astronomer Frank Drake in 1960 with his Project Ozma. Project Ozma launched the first radio signal search for extraterrestrial intelligence, or ETI for short. Throughout the decades since, SETI has suffered from fits and starts in its legitimacy by both the scientific community and politics in general. It has also expanded its search space possibilities from just radio signals from aliens to other more diverse forms of potential technosignatures. Fortunately, its scientific reputation and its vast potential to add to our knowledge of the universe has been accepted as very important branches of astronomy, physics, and biology. The original reasoning behind Cocconi, Morrison, and Drake's radio search for extraterrestrial intelligence was that if aliens develop any science and technology of their own, they will inevitably discover the universal laws and science of electromagnetism and will eventually be able, through their technology, manipulate and use them for their benefits. This entails engineering devices that create and transmit cheaply made radio and other electromagnetic signals. By doing so, ETI will have stumbled upon a technology that can work and be detected across the cosmos. By extension, a search for these artificial radio and microwave signals would be the best way to detect ETI across the vast distances of space. However, the universe naturally creates a cacophony of radio signal noise. These SETI pioneers identified some regions of the radio and microwave spectrum where the universe is naturally quiet and lends itself for ETI to take advantage of these quiet windows for sending signals at those frequencies. On the other hand, there is a multitude of very strong and noisy artificial radio signals that scientists have been frustrated by since the space age began. These are the signals coming from man-made technology that interferes with the search for ETI. Satellite and military transmissions, airplanes, cell phones, etc. So rather ironically, in SETI's search for artificial signals, there is a category of these transmissions that must be weeded out, and those are the terrestrial ones. What exactly, then, is it that scientists are searching for in these electromagnetic bands? After the weeding out and cleaning up occurs, SETI looks for signals that are left over. And preferably, they should be repeating or at least on for enough time for verification after repeat searches. Examples of signals that have been looked for are strong signals that stand out from the background noise, repeating signals, sequences of signals, signals that jump across multiple frequencies, also known as frequency hopping, and signals that drift across frequencies. So, in all of these decades of searching the skies in the radio and microwave bands, have we found any of these kinds of signals? The answer is absolutely yes, we have. It would be impossible to discuss each and every one of them in one or two videos, so we'll talk about some representatives. All of these categories of candidate signals have been detected. The identification of them, however, is the issue. The reasons are mostly due to either some of the signals' patterns being too close to those found to come from known terrestrial devices, such as certain satellites, or they're strong candidates that do not repeat, so they cannot be verified. The earliest and most celebrated candidate signal was called the WOW signal. For several years, a radio SETI search was being performed at Ohio State University's Big Ear radio telescope. On August 15, 1977, a strong radio signal had been detected and found in the printout recordings by astronomer Jerry Ehrman. In the printout, which listed all signal strengths over time, Ehrman found the standout signal and scribbled WOW on the paper. This signal has been labeled the WOW signal. The signal lasted 72 seconds and came from a part of the sky in the constellation Sagittarius. The frequency of the signal was 1420 megahertz and had a bandwidth of about 10 kilohertz, making it what is called a narrow-band signal, which is what SETI is looking for. This is because most of the radio signals that are naturally made from the universe are wide-band signals. A narrow-band signal would indicate an artificial origin. After many decades of repeated on and off searches of the same area of the sky for a similar signal, none have been found. What was the signal? The source has been hotly debated in science ever since, and all man-made sources have been ruled out. Its lack of repeatability has left us scratching our heads. Natural sources for any of these signals must first be eliminated before the much more extraordinary claim of extraterrestrial intelligence is made. Very rare natural sources or sources that are only theoretical must be examined. Could it have been a pulsar that only swept us once? A one-off radio burst from an unusual star phenomenon? Was it interstellar scintillation? Could it have been from a hydrogen cloud surrounding a passing comet? All of these ideas have been put forward, but have either been shown to be extremely unlikely or flawed in their reasoning. So, the WOW signal remains as one of the most interesting, unrepeating, but potentially alien signal detections. The closest star to the Sun is Proxima Centauri, about 4.2 light-years away. Around it circle several planets, one of which is Proxima Centauri b, located within the habitable zone of its star, where liquid water could exist on its surface. In April and May, 2019, a strong radio signal was detected from this stellar location and lasted the full 30 hours of the observation from the radio telescope. It was detected by the Breakthrough Listen project using the Parkes Observatory in Australia. This signal was labeled BLC1, short for Breakthrough Listen Candidate Signal 1. The signal's frequency was at 982 MHz. Later observations of the star were conducted, but the signal no longer appeared. Multiple re-observations could not find a signal. It seemed to be another one-off event. Again, without repeated observations of the same signal, it is impossible to confirm the nature of the signal. Later papers by the team concluded that the signal's structure resembled those found from Earth-based technology, and therefore were not of extraterrestrial origin, and were instead most likely from terrestrial radio interference. Are you beginning to see a pattern here? A candidate signal passes muster for SETI characteristics of artificiality. Then they vanish when reobserved. Due to their non-repeating characters, they are then assumed to most probably be of earthly or man-made origin, which, like it or not, is the scientifically correct way of approaching these scenarios. These aren't the only two radio signals found either. Signals like these have appeared frequently throughout the years. The real scientific answer for these types of signals are that we don't know what they are. Again, tantalizing ETI possibilities, but unconfirmed. Other notably representative head-scratching signals like these that have currently no confirmed explanations are: in March 2003, the SETI at Home project detected a weak signal 3 times in a row around the constellations of Pisces and Aries using the Arecibo telescope in Puerto Rico. It started at 1420 MHz, the so-called water hole region of the spectrum, and drifted fast in frequency from there. Re-observation never detected it again. In 2015, a signal was detected from this star, which is known to have at least one exoplanet orbiting it. The Russian Rotan 600 radio observatory had discovered the 2-second radio signal burst at 11 GHz. It did not repeat, and follow-up re-observations from other telescopes found nothing. In 2021, a paper was submitted to Nature Astronomy detailing the SETI search conducted on hundreds of stars over the course of hundreds of hours of observations. AI machine learning algorithms were used to analyze massive amounts of recorded radio data from these stars, and 8 good SETI candidate signals were found. These stars, again, were later reobserved and no signals remained. And these are only a few of the examples that have been found in our scientific observations. Since 2007, another unusual radio signal has been detected that has no widely accepted natural astrophysical explanation. These are fast radio bursts, or FRBs for short. These transient bursts of broadband radio energy, of which over 1,000 have been detected so far, last from less than 1,000th of a second to about 3 seconds. Whatever is creating them releases within a millisecond the same amount of energy as our entire sun does in a year or more. These are gargantuan energies. Most have been originating from within other galaxies, but some have been located within our own Milky Way galaxy. About 50 have been seen to repeat in erratic ways, but 2 have been found to repeat regularly. They don't appear to be traditional pulsars. These are rapidly rotating neutron stars that have radio jets that spin with them and that occasionally sweep past the Earth like a lighthouse. The reason FRBs can't be pulsars is that FRBs are many orders of magnitude more powerful and do not have the regularity or speed of repeatability that pulsars do. Several possible explanations have been put forward to help explain these mysterious bursts. Magnetars have been proposed. These are neutron stars, but with extremely powerful magnetic fields around them that may generate giant flares that become what we see as FRBs. Other possibilities for FRBs have included pulsars that are so massive that they eventually collapse in on themselves and become a black hole, radiating a burst of energy in one go during their collapse. Others are colliding neutron stars or companion stars that orbit around pulsars. And, of course, due to their very exotic natures, there is the suggestion that FRBs are intelligently created signals from ETI. Maybe they're meant to be beacons to attract attention, to signal their locations. Maybe they are due to some sort of large engineering projects or some kind of very advanced technology that just happens to be beamed in our direction. FRBs are still an exotic mystery, and a lot of current astrophysical research is devoted to studying them. Further research will allow us to paint a clearer picture of what these strange bursts of energy are. In this video, we discussed the realm of technosignatures in the radio and microwave stretches of the spectrum. These have been traditional frequencies that SETI has investigated, but there are many more regions to explore in the electromagnetic spectrum, such as with infrared or visible light, and through others that have also had some intriguing signals. We'll continue our discussion of those other searches in our final video of possible technosignatures. Until then, try to brainstorm on your own and attempt to guess what other ways science may use to search for evidence of alien intelligence. This is a vibrant and rich field that holds a potential wealth of opportunity in science. Let's keep looking. I'll see you in part 2 of Technosignatures. Please subscribe to Turtles All the Way Down to keep up to date on new and upcoming videos and content. Thank you. Bye for now.